Hi all, so this video I'm going to dedicate to Mr. UVU. Mr. UVU years ago actually took my class. Ben King was his name. I got to give him credit where credit's due. He's a pretty good artist and pretty good student as it turns out. I used to give quizzes in class and he would finish first and then just sit there and draw pictures, and I thought, well, it'd be kind of cool to have him draw a picture of radicals dealing with this stuff. So here's what he came up with. It's pretty cool. So hopefully you can see this. We're taking a look at the cubed root of x to the fourth times x cubed. And so he drew these little bugs and said, only groups of 3 can go. So this prison warden is actually the cube root guy. So as you can see, I've got 4 little bugs here and then 3 little butterflies here. The bugs represent the x's, the butterflies represent the y's. So only groups of 3 can come out. So 3 of those 4 beetles come out, becomes this X over here, and then all of the butterflies came out. But it's really sad because this guy was all excited about going out of jail, but as it turns out he's stuck inside of jail. So the long story short is our answer, sorry I'm having trouble getting this thing to fit on the overhead, is going to be xy, right, because they're groups of 3 that came out, times the cubed root of this last guy that's left inside, or the cubed root of x in this case. So we're going to use the idea of that comic to do these problems here. Those comics actually really help people, as I found out over the years. So let's simplify the square root of 18. The square root of 18, I guess I used black in there, is going to be, I'm going to rewrite this thing so that I've got, we're talking about square roots, right? So I'm looking for perfect factors, or perfect squares, if you will, that are factors of 18. And 9 times 2 is 18, right? So the 9 is the perfect square that I'm after. It's a group of 2 3's multiplied together. So those 2 3's will come out and become a 3. Or you can just think of it as the square root of 9 that comes out and just becomes a 3. And the 2 is going to be left inside the jail there, inside the square root. So that problem's done. Let's look at the cube root of 40. Now we're talking about cube roots, so I need to look at perfect cubes that are factors of 40. 8 is going to be that number. 8 times 5 is 40, and the 8 is 2 times 2 times 2, so that's a group of 3 2's that come out. So the cube root of 8 is the 2, the cube root of 5 is left inside. Now let's look at the square root of 14. My factors of 14, the only ones that are usable, there's 1, 2, 7, and 14, but if you want the prime factors, it's 2 and 7, and I don't have groups of 2 of those, so it turns out square root of 14, it's already done. It's a trick question. Now let's look at the 4th root of 162. Whoa, that's a big number. Okay, now it's getting a little hairy. So let me prime factorize. A lot of people like the factor tree to do this. 162, it's 2 times 81 is 162. And I know that 81, well, you know what? I could probably stop right there if I wanted. In fact, I will. No, it's a 4th root. Let me keep going. 81 is 9 times 9. And 9 times 9 is 3 times 3. Excuse me, 9 is 3 times 3. So my factors here that I'm looking at are going to be this 2 times 3 to the 4th, right? So I've got 4 3's that are going to come out. So it turns out 81 is a perfect 4th power. The 4th root of 81 is 3, as it turns out. Or you could look at it this way, where I have groups of 4 3's that you could pull out. That leaves us with the 4th root of 2 left inside. By the way, 3 times the square root of 2 is not the right answer. I'm going to use red to show that. That's not saying the same thing as 3 times the square root of 2. Those are 2 whole different items, okay? So just kind of keep that in mind.